For more problems and videos like this for linear algebra, you can take a look at Sarai Studies, link is in the description box below. In this video, we have two vectors u and v, and I'm going to show you how to add them, subtract them, and how to scale them. So we're told to add these two vectors. That just means add vector u plus vector v. Without even writing anything, you can just look at this. 3 plus 3, that's 6. 4 plus 1, that's 5. So that is the resulting vector. But ideally, our vector u is 3 and 4. You're doing plus vector v, which is 3, 1. So you do the same thing. 3 plus 3, 6. 4 plus 1, 5. This is your answer. What does that look like visually? Well, you can plot vector u. That means go 3 to the right and 4 up, starting at the origin unless otherwise specified. 1, 2, 3 to the right, and then 1, 2, 3, 4 up. That's my vector u. Then vector v is 3 to the right and 1 up. So 1, 2, 3 to the right, and then just 1 up. That's my vector v. And then the resulting vector, what you get from adding pink and blue vector, is 6 to the right and 5 up. So 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5. This is vector u plus vector v. Now let's subtract them. I want to do vector u minus vector v. So it's the same thing. You just do 3 minus 3, that's 0, 4 minus 1, that's 3. That's your answer. But to be specific, we're doing 3, 4 minus vector 3, 1, that's going to be equal to 3 minus 3, 0, 4 minus 1, 3. That is your resulting vector. What does that look like visually? Well, we already plotted these. This is vector u and this is vector v. But what is this? Well, this is vector u minus v. So that's 0 to the right, so it's just here, but 3 up. It's really just 1, 2, 3. So this here is vector u minus vector v. Finally, another cool thing that we can do is scale the vectors. So let's say that I have my vector u and I want to scale it by 2. All this means is just make it 2 times bigger. Visually, all that means is literally take the same vector and then add it to the end. Now it's the same vector, just 2 times bigger. So now this is 2 times vector u. But what that looks like here is really just 2 times vector u, which is 3, 4. That is 2 times 3, 6, and then 2 times 4, 8. So you just multiply this by every entry in that vector. And if you were to plot this, you would get this. That would be 1, 2, 3, 4, 5, 6 to the right, and then 8 up. So that would be 1, 2, 3, 4, 5, 6, 7, 8. Right here. And that's exactly what you get. You can also do something like 1/3 of vector v. So you can take 1/3 of vector v and make that your new vector. So algebraically, that's just taking 1/3 of your vector v, which is 3, 1. So this is really just multiplying to each entry inside. So that would be 1/3 times 3. Well, the 3's would cancel out. You'll be left with 1. And then 1/3 times this would just be 1/3. So our new vector would be this. So visually what that looks like, 1 to the right, and then 1/3 up. Right about here. So you can see it's literally 1/3 of your vector because 3 of these make up your vector. So you only took 1/3 of it, so therefore that's why this is literally 1/3 of your vector v. Now, to be specific, we call these scalars. We use them to scale our vectors up or down, or to the left, or to the right. Now, one more thing I wanted to mention. Let's say I had another vector called w, and it was just 1, 2, 3. And let's say that I said, okay, I want you to add vector u and vector w. So that would look like vector u, which is 3, 4, plus vector w, which is 1, 2, 3. Can you do this is the question. No, you cannot, because this has 2 entries, this has 3 entries. In order for you to add vectors, they have to be of the same number of entries. They have to be in the same dimension. This vector is in the coordinate plane in the 2D dimension. This is in the 3D dimension because it has 3 entries. It would be in a plane that looks like this, where this is z, this is y, and this is x. So you cannot add 2 vectors that are of different worlds, of different dimensional spaces. They have to be the same dimensional spaces. So here we had 2, here we had 2, so we could add. But here, that's undefined. And that's it for this video. I'll see you in the next.